pop out this, pop out chat. All right. Maybe I'll just send it here. Yeah, I still haven't learned the i3 manager. I forgot. How do you do this? Yeah, well, I'll just send this actually at 4. No one's coming to the stream. Anyway, wait. All right. What's playing in the background is Alka Crab. Free 8 piano instrumental tracks. Game music pack. This is nice. All right. So the A personality language item. Language items are special functions and types that are required internally by the compiler. The copy trait. What are traits? It's just the thing with Rust. What are traits? What are traits in Rust, let's say, compared to Nexos? Compared to Nix or to Nix or Haskell? What are Rust traits? Oh, type classes. Defining a shared behavior that multiple types can adhere to without specifying how that behavior is accomplished. Rust traits, a set of required methods that a type must implement. It's a type class. Trait display defines a FMT function which is implemented differently for each type that implements display. So in Haskell, type classes are similar and they define a collection of functions that a type must provide. Nix does not have traits, does not have an equivalent to traits or type classes. Nix functions are dynamically typed and rely on a functional declarative style. Yeah, accept or operate on specific attribute set. I guess this is like the file set library by Sylvan. Basically, these are some traits. Here is how a basic trait works. Trait summable, fn sum self I 32, struct numbers vec, implement summable for numbers self I 32 self. Yeah, this looks so wow. Well, let's move on. While providing custom implementations of language items is possible, it should only be done as a last resort. The reason is that language items are highly unstable implementation details and not even type checked, so the compiler doesn't even check if a function has the right argument types. Fortunately, there is a more stable way to fix the above language item error. The A personality language item marks a function that is used for implementing stack unwinding. By default, Rust uses unwinding to run the destructors of all live stack variables in case of a panic. This ensures that all used memory is freed and allows the parent thread to catch the panic and continue execution. Unwinding, however, is a complicated process and requires some OS-specific libraries. So we don't want to use it for our operating system. Disabling unwinding. There are other use cases as well for which unwinding is undesirable, so Rust provides an option to abort on panic instead. This disables the generation of unwinding symbol information and thus considerably reduces binary size. Abort on panic. Okay, there are multiple places where we can disable unwinding. The easiest way is to add the following lines to our cargo toml. Where do we put the cargo toml? So code impros. ls source. Cargo, oh, it's right here. Cargo toml. Cargo toml. Impros. Addition. Dependencies. Profile dev. Add the following lines. So we gotta add the following lines. Profile dev. Panic abort. Profile release. Panic abort. Okay. This sets the panic strategy to abort for both the dev profile used for cargo build and the release profile used for cargo build release. Now the A personality. This kind of what personality language item should no longer be required. Now we fix both of the above errors. However, if we try to compile it now, another error occurs. All right. So let's do cargo build. Consider adding a main function. So I do have to be in the source. Right, let's try here. Consider, no, I don't have to be. Could not compile due to 2 previous errors. An inner attribute is not permitted following an outer doc comment. What? Cargo build error requires start lang item. What did I source? This function is called on panic. Maybe because it's maybe like because of 3 slashes? No, really? The inner attribute doesn't annotate this function. An inner attribute is not permitted in this context. Inner attributes like noSTD annotate the item enclosing them and are usually found at the beginning of source files. Consider adding a main function. Could not compile due to 2 previous errors. Requires start lang item. Well, maybe now this doesn't work. One might think that the main function is the first function called when you run a program. However, most languages have a runtime system, which is responsible for things such as garbage collection in Java or software threads, Go routines in Go. This runtime needs to be called before main, since it needs to initialize itself. In a typical Rust binary that links the standard library, execution starts in a C runtime library called C runtime 0, which sets up the environment for a C application. This includes creating a stack and placing the arguments in the right registers. The C runtime then invokes the entry point of the Rust runtime. Which is marked by the start language item. Rust only has a very minimal runtime which takes care of some small things such as setting up Stack Overflow guards or printing a backtrace on panic. The runtime then finally calls the main function. So there is a C runtime library in Rust. Our freestanding executable does not have access to the Rust runtime and CRTO, so we need to define our own entry point. Implementing the start language item wouldn't help, since it would still require CRTO. Instead, we need override the CRTO entry point directly. Overwriting the entry point. I guess this will fix the main problem. To tell the Rust compiler that we don't want to use the normal entry point chain, we add the no main attribute. Well, no std. We don't even oh my, it's not working, the caps thing. Oh, I forgot to. This kitty is kind of slowish. Wait, was it here somewhere? What did I write? Yeah, I was remapping tab. And I just want to find it like this. I should search for it. This. Yeah, I should put this in. Really, I should put this. Caps escape. Or not. Maybe I will learn Emacs. Not sure. Okay. So we're putting the no std and no main. Right. An inner attribute is not permitted in this context. Panic handler. The inner attribute doesn't annotate this function. Inner attributes, like noSTD, annotate the item and closing item and are usually found at the beginning of source files. Panic handler, function required but not found. What does this mean? But it's here. You might notice that we removed the main function. The reason is that main doesn't make sense without an underlying runtime that calls it. Instead, we are now overriding the operating system entry point with our own start function. No mangle. No mangle. We disable name mangling to ensure that the Rust compiler really outputs a function with the name start. So we delete this? No mangle. Do we keep the panic function? Panic handler. Oh, but there's a mistake here. Yeah, let's try like this. Due to one previous error. Failed, linking failed. Linking with CC. Am I missing a tool? Am I missing a tool? So on my Linux, maybe I'm missing something. System libraries. The CC compiler. Sure, the C toolchain is installed. Build essential. Rust up update. Rust up update. Will I have Rust C? Maybe because of the main function. Okay. You might notice that we removed the main function. The reason is that main doesn't make sense without an underlying runtime that calls it. Instead, we are now overriding the operating system entry point with our own start function. No mangle. So I don't know, is it... So is this... Do we add this? Or like... Wait, Rust traits. No, it's not this. Terminal. Yeah, I'm not sure. Linker errors. He did write the blog is openly developed on GitHub. The complete source code for this post 1 branch. Let's check GitHub. 5 years ago, 6 years ago. So source, let's check out source. Main. No mangle. Oh, he put it before. Okay. Okay. So now we're going to write the no mangle pub extern C fn start and we're going to do what? This is also a divergent function. Yeah, divergent function and a loop. All right, we know this from before, that we've seen this thing. Well, it's not an argument. Okay, pub extern fn start. I guess these are the arguments, and they output this type, which is a divergent type, which does what? And this is the body of the function. Yeah, can you explain? I need to... The explanations are kind of nice here, but he explains it like what happens. I really need, you know, something that kind of explains the evaluation itself. So can you explain the evaluation itself? Yeah, breakdown of each part. The code snippet demonstrates how to define a custom entry point in Rust, often used in low-level systems programming, such as when building operating systems. No mangle, not to mangle the function name, which means it won't modify to follow Rust's typical naming conventions. Why do we need that? In compiled programs, function names often get modified or mangled. Mangle. Yeah. I mean, to mangle is such an unprecise word. To encode additional information, like namespaces and types. However, for a function like start, which is intended to be called directly by the operating system or loader, we need the exact name to stay intact. The no mangle attribute ensures the function name in the compiled binary remains start. And this pub extern cfn start, pub makes the function public, so it can be accessed outside of its current module or crate if necessary. Okay. Okay, I guess I'm familiar, like I know only in Java, they're like public and C++, I guess. Public and private, which are also names I'm not too fond of. Extern C specifies that this function should use the C calling convention, not Rust's. Extern C. Oh wow, this convention is essential for interoperability with system-level code, as most operating systems expect the entry point to follow C conventions. Start is the function name when no standard runtime is linked. The return type, special type called the never type, signifies that this function never returns or diverges. In this case, indicates that the function will either loop indefinitely, halt, or cause the system. Loop creates an infinite loop. But you might replace loop with code that performs initialization tasks. Okay, but what are the arguments and the body of this function? The start function is intentionally minimal, but in a typical operating system, start usually has the body here is simply loop. Okay, no mangle. Initialize the stack pointer. Assembly. Initialize memory and data structures. Initialize memory. Set up interrupts. Hand off control to the main kernel loop. Okay. So by using the no mangle attribute, we disable name mangling to ensure that the RISE compiler really outputs a function with the name start. Without the attribute, the compiler would generate some cryptic ZN3 blog. The attribute is required because we need to tell the name of the entry point function to the linker in the next step. We also have to mark the function as extern C to tell the compiler that it should use the C calling convention for this function. The reason for naming the function start is that this is the default entry point name for most systems. The return type means that the function is diverging, not allowed to ever return. Yeah, diverging. Entry point is not called by any function, invoked directly by the operating system or bootloader. So instead of returning, the entry point should invoke the exit system call of the operating system. Well, there's a lot of information here, you know, and maybe this is just, okay, everybody, I mean, I saw some of the comments online and this tutorial was praised, but now I'm kind of talking something as someone who teaches guitar, classical guitar. It's like you almost expect like more code and less explanations, or kind of that the explanations are embedded in the code. So I think it even helps like to type a little bit. Yeah, probably I'll have to find a stream or when someone is kind of typing or and you know, writing a little bit of code, and so that the explanation itself, or maybe this is the, yeah, with functional programming, it's like the code is, for me, I don't know, the code is somehow more connected with the explanation. I'm not making much sense now, yeah. The function is diverging. This is required because the entry point is not called by any function, invoked directly by the operating system or bootloader. So instead of returning, the entry point should invoke the exit system call of the operating system. Shutting down the machine could be a reasonable action, okay? Cargo build, we get an ugly linker error, linker errors. The linker is a program that combines the generated code into an executable. Since the executable format differs between Linux, Windows, and Mac, each system has its own linker that throws a different error. Okay. Well, the fundamental cause of the errors is the same. The default configuration of the linker assumes that our program depends on the C runtime, which it does not. To solve the errors, we need to tell the linker that it should not include the C runtime. We can do this either by passing a certain set of arguments to the linker or by building for a bare metal target. Oh, I see. So it's like you can tell this to the linker, or I guess you can put it in the code because you're building it for someone else. Building for a bare metal target. By default, Rust tries to build an executable that is able to run in your current system environment. If you're using Windows, Rust tries to build an executable Windows This environment is called your host. To describe different environments, Rust uses a string called target triple. You can see the target triple for your host system by running rustc version verbose. Wait, did this save? Oh, it didn't save. Is there an undo button? Ah, not when I go out of the program. Oh, that's too bad. Wait, I have to write this again. No mangle. Pub extern C fn start loop all right, let's save this and rustc version verbose binary host unknown Linux GNU LLM. All right. Yeah. So the above output is from a Linux system. We see that the host triple is 64-bit unknown Linux GNU, which includes the CPU, the vendor, the operating, and the ABI. Application binary interface. By compiling for our host triple, the Rust compiler and the linker assume that there is an underlying operating system such as Linux or Windows that uses their C runtime by default, which causes the linker errors. So to avoid the linker errors, we can compile for a different environment with no underlying operating system. An example of such a bare metal environment is the target triple, which describes an embedded ARM system. The details are not important. All that matters is that the target triple has no underlying operating system, which is indicated by the none in the target triple. To be able to compile for this target, we need to add it in rustup. Wait. Oh, this is just an example of ARM system. Okay, this downloads a copy of the standard and core library for the system. Now we can build our freestanding executable for this target. Okay, we're not going to do this because I guess he's just giving an example how to build for an embedded system. Right, yeah, you pass this and you build for that target. So by passing a target argument, we cross-compile. All right, that's cross-compiling our executable for a bare metal target system. Since the target system has no operating system, the linker does not try to link the C runtime, and our build succeeds without any linker errors. This is the approach that we will use for building our OS kernel. Instead of, we will use a custom target that describes 8664 bare metal environment. The details will be explained in the next post. So instead of compiling for a bare metal system, it is also possible to resolve the linker errors by passing a certain set of arguments to the linker. Okay, this is the second approach. This isn't the approach that we will use for our kernel. Therefore, this section is optional and only provided for completeness. Click on linker argument below to show the optional. So in this section, we discuss the linker errors that occur on Linux. All right, this is what I got. The problem is that the linker includes the startup routine of the C runtime, also called start. Requires some symbols of the C standard library that we don't include due to the noSTD attribute. Therefore, the linker can't resolve these references. We can tell the linker that it should not link the C startup routine by passing the no start files flag. Rust command. Oh, the command behaves exactly like cargo build, but allows to pass options to the Rust. Okay, so we can use Rust to pass options to the cargo build. Rust has the C link arg flag. It's a flag which passes an argument to the linker. Combined, our new build command looks like this. So if we do cargo Rust C and we do the to that link arg no start files, expected type could not compile due to one previous error. It's interesting. Well, let's see. And our program I'm curious about my source is this. Because the function signature lacks a return type. You specify a type for the return value, even if it is the never type. To fix this, modify your function as follows. fn start loop. What did it change? Pub extern C fn start. Well, it didn't change a bit. Oh. I think I forgot. I think I forgot. Wait. So it should be this. Yeah, let's try again. Oh, now it works. Compiling. Nice. Dev profile. All right. Let's make it just a screenshot. So let's move on. Now our create builds as a freestanding executable on Linux. We didn't need to specify the name of our entry point function explicitly. Maybe I should write something. Hello, I'm building an operating system in C in Rust following a tutorial. I don't know Rust, so it's gonna take a while. Okay. It should be boring. Wait. So, okay. We didn't need to specify the name of our entry point function explicitly, since the linker looks for a function with the name start by default. On Windows, a different linker error occurs. Okay, now I'm showing it on Windows. The entry point must be defined means that the linker can find an entry point. On Windows, the default entry point name depends on the used subsystem. For the console subsystem, the linker looks for a function named main_crts startup. And for the Windows subsystem, it looks for a function named win_main_crts startup. To override the default and tend the linker to link to our own start function, instead we pass the entry argument to the linker. Yeah, okay. This is for Windows. We're not on Windows. Now a different linker error occurs. Okay. This error occurs because Windows executables can use different subsystems. For normal programs, they are inferred depending on the entry point name. If the entry point is named main, the console subsystem is used. Okay. Okay, that's too much now. On Mac OS, no. Does not officially support statically linked binaries and requires programs to link the lib subsystem library by default. Yeah, you see, each system is different. To override this, we pass the static flag to the linker. Oh, I see. Well, that's good to know, you know. This still does not suffice as third linker error occurs. This error occurs because programs on Mac OS, by default, this is similar to the error we had on Linux and can also be solved by adding the no start files linker. Now our program should build successfully on Mac OS, unifying the build commands. Right now we have different build commands depending on the host platform, which is not ideal. To avoid this, we can create a file named cargo config toml that contains the platform specific arguments. Oh. So this is when our program compiles on Windows or Mac OS the Rust flags. Cargo. Is there a cargo? Look, it's get. It's initialized already. Oh, wow. So where do I put this? In cargo. Oh, is it in the home directory? It's here. Config toml. Well, I'm just gonna copy this. No. Now our program should be buildable on all three platforms with a simple cargo build. Should you do this? Well, it's possible to build a freestanding executable for Linux, Windows, and Mac. It's probably not a good idea. So the reason is that our executable still expects various things. For example, that a stack is initialized when the start function is called. Without the C runtime, some of these requirements might not be fulfilled, which might cause our program to fail through a segmentation fault. If you want to create a minimal binary that runs on top of an existing operating system, including libc and setting the start attribute as described here, is probably a better idea. What's here described? Oh, this is with no std. Using libc. Look at the mangle function. No mangle. Personality. Okay. But look, this is too complicated. Yeah, that's the thing that I don't like about imperative programming. And loops. Oh, why am I so, I have some kind of aversion with loops. If you want to create a minimal binary that runs on top of an existing, okay, a minimal freestanding Rust binary looks like this. Cargo toml. So we are not going to save this. All right. So don't link the Rust standard library, disable all Rust level entry points. Let's check our code in pros source source. Oh, it's here. Cover. Let's do PNG cover. Let's move cover to. All right. So main. No main RS. Disable in main RS. I guess this is confusing now. So no std, don't link the Rust standard library. So don't link the Rust and no main, disable all Rust level entry points. Use core panic info. This function is called on panic handler. Oh, I should copy this. How do I copy this? Okay, I know I have to like group it. And how do I cut? Yeah. Wait, I have to. I'm not sure how you do this. Helix copy paste. Copy to clipboard commands. Well, maybe like this. Yank, paste. Yank selection. Cut. Space. Go to. What did I do? Undo. Delete. Yeah, I'm not sure. How do you surround yank? Is it yank? Is it yank? Is it yank? Yank. No, it's not. I want to cut. Yank. Where do you yank? Yeah. How do you cut? Yeah, helix editor cut. What's the cut? Okay. I need to this kitty is slow. Timer. Countdown. What's the name? Countdown. Well, I'll say I'll be back. Oh, I think I kind of muted myself. Yeah, I pressed the wrong button. Security. All right, what's next? Support me. A minimal Rust kernel. So let's move on. Now we are at 1 hour and 8 minutes. So now we are at the minimal Rust kernel. So a freestanding binary and minimal Rust kernel. So I could, in Rust, I could rename it. Freestanding binary and minimal Rust kernel. Freestanding binary, minimal Rust kernel. All right, I'll just rename it. So maybe I should stop now, yeah. 6:30, yeah. I'll stop now and I will have to stop soon. My son will wake up. It's 6:35 a.m. All right, so bye-bye.